Good day! Here is the performance of Group 5, the activity number 3, 4 basic concepts of mathematics and elementary logic. We will going to show to you how again math play its role in every category we can name. Today, we are going to tackle about and give some examples about 4 basic concepts of mathematics and elementary logic.
A set is the mathematical model for a collection of different things. A set has elements or members which can be any mathematical object, numbers, symbol, points in space, lines, other geometrical shapes, variables, or even other sets. In mathematics and logic, a set is any collection of objects whether mathematical or not. A set is typically represented as a list of all its members surrounded by braces. The intuitive concept of a set is likely even older than the concept of number.
I'm having a hard time to find an example of set, but let me try to check in our kitchen.
How about the utensils? The cups and plates keep separately. But wait, this is one of example of sets. You see, math is everywhere.
What is relation? Relation is any set of ordered pairs. The set of all the x components, the ordered pairs, is called the domain of the relation, and the set of all the y components is called the range. So, okay, we have example number 1. Here is our set of ordered pair. Our set A has 1, 2, 2, 3, 3, 4, and 4, 5. Okay, so next, what do we put here in our domain or in our values of x? So our relation says, here all our first elements, so what exactly comes first? 1, 2, 3, and 4. So now, 1 is partner is 2. So where will we meet? Here, so of course, we will just put a line which means 1 is our domain and 2 is the range. Because this is 1, 2, our ordered pairs. Next is 2, then the partner here is range 3. Next is 3 and 4. Last is 4 and 5. So you can see that he has never had a relation. He is loyal to his partner or his pair, which means that we will call it 1:1. Our relation will be functions. So let's put in here at x is 1, 2, 3, 4. First element, the input. X is equal 1, 2, 3, 4. And second element, our output, y is 2, 3, 4, 5. Next, we will look at the relations to see if 1 is to 1, 1 is to many, or many to 1. Now, 1 is partner is 2. So, where will we meet? Here, so of course, we will just put a line which means 1 is our domain and 2 is the range. Because this is 1, 2, our ordered pairs. Next is 2, then the partner here is range 3. Next is 3 and 4. Last is 4 and 5. So you can see that he has never had a relation. He is loyal to his partner or his pair, which means that we will call it 1:1. Our relation will be functions.
Function is a relation such that each element of the domain is paired with exactly one element of the range. Ways to verify if a relation is function or not. First, table. Second, ordered pair. Third, mapping. Fourth, graph. The value of x is paired with exactly one element of the range. The value of x is have one y. X should only pair with y. All function are relation, but not all relation are function. The mapping. 1 to 1, many to 1, 1 to many, and lastly, many to many. This is the example. You just need to get the f of x and value of x. As you can see in this picture, you just need to substitute what is the f of x and value of x, then solve and get the final answer. And lastly, that you will do, you need to create a graph to your answer.
Binary operation in mathematics. A binary operation on a set is a calculation that combines two elements of the set, called operands, to produce another element of the set. Meaning, a binary operation asterisk on the set of the real numbers is a rule which combines any two real numbers a and b and gives a real number. Example, include the familiar elementary arithmetic operation of addition, subtraction, multiplication, and division. Other examples are readily found in different areas of mathematics, such as vector addition, matrix multiplication, and conjugation in groups.
A binary function. As illustration, consider a function g for reals cross and reals to reals defined as follows. G of b is equal to a plus b addition on the real number is a binary operation that requires each pair of real numbers and maps it to precisely. One more real number is formally the domain values of g are ordered pairs. So you might think it's better to write g of the pairs order AB, but it's common to omit the extra parentheses. However, keep in mind that the Cartesian product R times R is the set containing all order. pairs R1 and R2, where R1 and R2 are really numbers. So the domain values here are technically ordered pairs, and that's what A stands for.
Proposition is a declarative sentence that is either true or false but not both. Example, 3 is an odd integer. Quezon City was once the capital of the Philippines. 12 divided by 4 is equal to 7. Square root of 3 is an integer. 1, 2, and 3 are proposition while 4 is not a proposition. Logical connectives are the operators used to combine the proposition. The logical connectives example and truth tables are given. So this is the table. Negation, example, is not the case that 5 is positive. Conjunction, example, 2 is an even integer and 3 is an odd integer. Disjunction, example, students who have taken MMW or information technology but not both can take discrete mathematics. Conditional example, if it's rain then the ground is wet. Biconditional example, the polygon is triangle if and only if it has 3 sides.
A denial of a statement is the negation of any form of the negation. In other words, a denial is the process of forming the contradictory of the given statement. A denial is a statement equivalent to the negation of a statement. Example, 1. The negation of P is Q is not P then Q. Number 2. A denial of P then Q is P and not.
A tautology is a statement which is always true. Example, I will give you 10 apples or I will not give you 10 apples. These two individual statements are connected using logical operator, or which generally denoted by the symbol letter B. Thus, the above given statement can be written as a P or not P. Now, we will check whether the given statement produces a valid answer with the help of the truth table. If the first statement is true and the second statement is false, therefore the truth values is true. And if the first statement is false and while second statement is true, thus the truth value is true.
A proposition is theory formed by contradicting both the subject and predicate, or both the hypothesis and conclusion of a given proposition, or theorem and interchanging them. If not B, then not A, is the contrapositive of if A, then B.
Contrapositive example. If you are a student, then you hate homework, so P is being a student, and Q is hating homework. The converse would be, if you hate homework, then you are a student. Then you would take the inverse of that and get, if you love homework, then you are not a student.
Predicate is an expression of one or more variables defined in some specific domain. A predicate with variables can make a proposition by either quantifying the variable and assigning a value to the variable. For example, let E x y denote x equal y. Let x a b c denote a plus b plus c equals 0. Let m x y denote x is married to y. Here's another example where you can identify the subject. The cat is playing. The cat denotes the subject, the object or entity that the sentence is about. Is playing denote the predicate, a property that the subject can have.
A quantifier is a word or phrase which is used before a noun to indicate the amount or quantify some, many, a lot of, and a few. Are example of quantifiers. Quantifiers can be used with both countable and uncountable nouns. There are two types of quantifiers, universal quantifier and existential quantifier. Universal quantifier is a logical quantifier that asserts all values of a given variable in a formula. Its formula is all x satisfy p of x also satisfy q of x. Existential quantification is a type of quantifier, a logical constant which is interpreted as there exists, there is at least one, or for some. It is usually denoted by the logical operation symbol existential, which when used together with a predicate variable is called an existential quantifier. Its formula is some x satisfy p of x also satisfy q of x.